Hi everyone, welcome to my channel I Learn. In this series, we will be looking at the basic Catia tutorials. In the last video, we looked at the graphical user interface of Catia, and today we will be using different tools to create 2D profiles for creating three-dimensional models. If you are new to my channel, please like and subscribe, and if you are returning back, don't forget to hit like and subscribe button. So without wasting any time, let's get started. As I said in the last video, we will be looking into the sketcher and part design in this series. However, since most of the function of sketcher is included in the part design, we will be looking in the part design only. So to get started, let's click on the start menu to mechanical design and then to part design. I'll leave the name as the default one and just hit OK. This is where we left at the last video as well. So in order to create a 3D model, first we need to have a 2D profile. And to create a 2D profile, we need a planar surface on which we will be going to create a 2D profile. Now I will select a plane. Here I have selected a YZ plane. You can see the plane that I have highlighted is reflected here in the specification tree as well. It's the YZ plane. So I will move my cursor to the sketcher icon. You can see on the tooltip it is written sketch. I will click it and I will enter into the sketcher mode. You can see two axes and the grid lines. If you are unable to see the grid lines, maybe it is turned off. You can enable or disable the grid line by clicking on the grid icon. Now clicking on the profile tool, we will create a random profile. So first it will create a straight line, and then we can select a tangent arc. This will create an arc that is tangent to our previous line, and again it will resume to the straight line. In this way we have created a random profile. For this example purpose, I will be creating multiple profiles within the same window. So to remove the last profile that we created, I will click and select all the profile and press delete button. Now we will be creating a rectangle. In order to create a rectangle, click on the rectangle tool as shown on the screen. The vertex of the rectangle can be placed anywhere on the screen. I will place the vertex on the origin. As you can see, I can move my mouse to create a rectangle of different dimension. If you notice closely, I am able to place the vertex only at the grid points and not in between it. This is because I have enabled snap to point, as you can see on the screen. If I disable it, I can place the vertex anywhere on the screen. As you can see, we have created a rectangle. In this rectangle, the two adjacent lines are in green and the remaining two are in white. Catia helps the user in identifying the graphical properties of the element by following standard code. The white color represents unconstrained element. This indicates that still some degree of freedom remains unconstrained. The green represents iso-constrained elements. This indicates that all relevant dimensions are satisfied. Similarly, yellow represents non-modifiable element. This indicates that these elements cannot be graphically modified. Similarly, gray represents construction element. These elements are used as positioning references. The red-orange indicates the element is selected. The purple color indicates too many dimensions are applied to the geometry. and the brown color indicates that some geometrical elements are overdefined or not consistent. As we create different profiles, we may come across all of these colors. We need to define dimension to the white lines to make them constrained. This can be done by clicking on the constraint tool, as you can see on the screen, and then selecting the line. Similarly, the other line. I will modify the height of the rectangle to 70 mm and the length to 150 mm. So you can see all the lines are green and all are constrained. Clicking on the down arrow on the rectangle profile gives access to other rectangle options. Here we have the oriented rectangle, the parallelogram, elongated hole, cylindrical elongated hole, keyhole profile, polygon, centered rectangle, and centered parallelogram. If I select on the oriented rectangle, this will create a rectangle with 3 points. So first I will click a point and then another point, and based on the third point I can create a rectangle. Similarly, for the parallelogram, we need to click the 2 points and the third point. Based on the third point where we click, it will create a parallelogram. For the elongated hole, I select 2 points and then draw my mouse perpendicular to that. As you can see, this profile is all white, so I will give a constraint to it, and let's say the length to be 120 millimeter and length from the center to the parallel lines, say 50 mm. This 50 mm is also, if you see, the diameter of the semicircle at the ends of the rectangle. This profile is basically a rectangle with 120 by 100 mm with two semicircle of diameter 100 mm at the ends. But still the profile is all white in color. What happens if I define the radius of the semicircle? To do that, I'll go to the constraint and click one of the semicircles. Oh, look at here. The sum of the dimensions are over constrained. And I hope you know why it is over constrained. And press the escape key. Can you guess what could be missing to make this profile fully constrained? If you look closely, I can move this profile horizontally and vertically. Because of these two, we are unable to get a all green profile. So let's work out to get a fully constrained profile. So first thing what I can do is create a dimension that is at a certain length from the horizontal axis. I have defined the distance from the horizontal axis to the bottom horizontal line to be 50 mm. So once I do that, you can see the two horizontal lines are green in color. This means they are now constrained. Now I can move the profile only horizontally, as you can see on the screen. To make the remaining semicircle constrained, I need to define a distance of center of one of the semicircle from the vertical axis. To do this, I will click center of one of the semicircle, click Control and select the vertical axis and click on constraint, and I will give it length of, let's say, 40 mm. So as soon as I give the length, you can see the whole profile is now green. That means I cannot move the profile horizontally or vertically, and now they are fully constrained. Now let's move on to creating circle. To do that, click on the circle profile and select the center. For this, I will select the center at the origin and just move your mouse outwards of it. So this is how we create a circle. To give it dimension, create a constraint, and I'll just give it 200 mm diameter. So this is how we create a circle. And if you click on the down arrow on the circle profile, we have other options of creating circle and arc. So second is this 3-point circle. To do that, we need to select 3 points, and based on that a circle is created. Similarly, we can create a circle using coordinates. So the center point we need to define on H and V and the radius of that circle. So I'll create a radius of 100 mm and centered at the origin 0 mm and 0 mm. So this will create a circle. Similarly, we have a tritangent circle. For this you need to first draw 3 straight lines. So I have drawn here 1 straight line, 2 straight line and 3 straight lines. So for that, I will, after drawing the 3 straight lines, I will click on the tritangent circle and select the 3 straight lines that I have just created. Based on this, a circle is created. Similarly, we can create a 3-point arc. To do so, select the start point of the circle, select the second point of the arc, and select the third point of the arc. If you see the arc is white in color, this means that it is not fully constrained. So I'll select the arc and give a radius of, let's say, 500 mm. Okay, it's all right. So still it is not green in color. So what can I do? So this means that I can move the arc anywhere, so as you can see on the screen. So if I could select the 2 extreme ends of the arc and make them fix, then I hope that it will be fully constrained. To do so, I am going to select the 2 extreme points of the arc by using a control key, and then go to the constraint defined in dialog box. This is just above the constraint tool. So once I click it, I have a constraint definition. So I'm going to click on the fix and click OK. So now you can see the arc is green in color. This means it is fully constrained. There is also an option of creating a 3-point arc starting with limits. So first we need to click on the first starting point of the circle, the end point of the arc, and then we need to create a midpoint or the second point of the arc. And likewise, we can create an arc. For this, we need to define the center. The first click will be the center, and then once you have the desired radius, click on the starting point of the arc and get all the way to the end point of the arc. In this way, we can create different arc and circles with different options that is available on the Catia. To create a spline, we will go to the spline, and once it is selected, we keep on creating a random spline. Once you are finished creating the spline, double click on the end point, and that will be the end of the spline. Splines can be closed loop or open loop. Eclipse can be created using a 3-point, first above the major axis and above the minor axis, as you can see on the screen. To create a line, click on the line tools and create line of your choice. You can see every time I need to create a line, I need to select the line tool. If I don't want to do it, I can just double click the line tool, and I can draw as many lines as I want. Once I complete drawing all the lines, I can use the escape key to remove the selection. Similarly, we have the options of infinite lines, bisecting lines, bitangent lines, and line normal to curve. Below the line profile, we have the axis. You can create a horizontal and longitudinal axis with selection of this profile, and the axis will be represented by a dotted line. Similarly, we can create a point at random. Also, we can create point using coordinates, equidistant point for say in a line, and intersection point, projection point, and align points. As you do more and more practice of 2D sketches or 2D profiles, then you will use all of these points and all of these profiles. So in the next video, we will be looking into the operations that can be performed on the 2D sketches. Stay with me, and thanks for watching.